everyone, I'm Jingchen. Today I am sharing the Pixal3D project. It is an image-to-3D modeling project. In this video, I'll give you a comprehensive breakdown of how to use this 3D project to generate a detailed 3D model from a single image. Some of you might have seen other creators cover this project before. In this video, I'll share things that other creators haven't mentioned. These are tips I've learned through extensive testing. As you can see from the opening demo, results are really impressive. To get great results with this 3D project, there are quite a few details you need to pay attention to. First, let me clarify, Pixal3D works best for chibi characters, small figurine modeling, or relatively simple single assets. It is not suitable for realistic human models or complex models. Even those closed-source 3D projects still have a lot of room for improvement when it comes to realistic humans. Now, the generated models are more than sufficient as static assets, perfect for 3D printing small figurines. If you want to use them in games or need more detailed results, you'll need additional steps like part separation, decimation, retopology, baking, rigging, and more. As said, using this workflow to generate a model with no overlapping parts, clear outlines, and almost no holes will already save you a lot of work time. The idea behind this workflow is to standardize everything starting from the image generation phase. First, make sure the image you are converting to 3D is suitable and go through standard image processing, standardizing dimensions, and removing the background. Then using SeedVR2 for upscaling and texture restoration. Then using the parameters I've tested that improve result quality for sampling and generation. And finally export and view the 3D model. First, let's talk about preparing your input image. For the image generation part, if you already have a suitable image, you can just use that. If not, use these fixed prompts I've prepared plus your own prompts. Whether you're using open-source image models or closed-source ones, you should be able to get images that meet the requirements. For example, for chibi characters, the core prompts are full body, single character, a pose, or any pose, where limbs aren't overlapping. Subject-centered, 2/3 slightly turned front view, clear outline, clean white background, even lighting. No harsh shadows, no props blocking the body, all to ensure the image has clear structure and outlines. I recommend a resolution of at least 1024. Aspect ratio should preferably be square. As long as the subject is complete, the larger the subject takes up the frame, the better. Here I've included fixed prompt suffixes for both characters and props. Just put your own prompts in front when using them. If you're generating IP-related images, I still recommend using GPT Image-to. It is unmatched in this regard. Just sign up for an account. Free accounts get 6 to 7 G generations per Dalton Y for free. Back to the workflow. Feed your suitable image into the workflow. For image processing, first, use this image resize node with padding mode to pad it with white into a 1536 times 1536 square. Keeping the original image centered, square images make the generated model subject more stable. Next is background removal. Although Pixal3D has its own background removal process when running, but I noticed that all the official demo images have transparent backgrounds, so it is worth spending a few seconds to remove the background first. Third step, upscale with SeedVR2 to make the image textures sharper, so Pixal3D can better align pixels to the 3D model later. Upscaling from 1536 to 4096 is a good ratio, especially if your original image is a bit blurry. Directly restoring it might not give good results. You can downscale it first, then upscale it to get a sharp upscale. Fourth step, Pixal3D sampling and modeling parameters. First, enable low VAV RAM in my tests. Even with 48 GB of RAM online, without it enabled, even at low resolutions and polygon counts, you might still run out of RAM. For resolution, try to use 1536. It is a noticeable improvement over 1024. Set the camera view resolution to 2048. Set the texture map size to 4096. To preserve as much texture detail as possible, I am using 500,000 polygons here. which is much better than lower polygon counts. This polygon count is perfect for 3D printing small figurines. Even if you're using it in a game, I still recommend generating a high poly model first, then use decimation tools in your modeling software. Prioritize getting a clear, detailed model first. Letting Pixal3D generate a low poly model directly will likely result in poor quality, and you'll end up spending more time fixing it. Retopology is also a must enable. It helps fix some holes. If you still get holes occasionally, you can increase the shape sampling steps or just run it a few more times. Also, among these parameters, those starting with SS mainly control the overall structure and large outlines. The default recommended parameters are usually sufficient. The shape group mainly controls geometric refinement, affecting model details and surface stability. If you keep getting holes, you can slightly increase the sampling steps. X-related parameters control the texture mapping phase, affecting texture clarity and surface material appearance. You generally don't need to modify these three groups frequently. Start with the recommended parameters and adjust specifically when you encounter issues. Once you get the results, you can export the model in GLBJ style formats. When exporting, click the first button in the preview window. Then click Export and click the button and select the format you want to save. The preview in ComfyUI might look very dark. You can upload the saved model to the website I noted and adjust these parameters. The model will look more natural. Finally, since I use an AMD GPU, and this project relies on CUDA, I can't test it locally. Also, the official recommendation is 24 GB of RAM or more, which most people probably don't have. And to get good results with the parameters I recommend, I still suggest running it on an online machine, like the 48 GB RAM instances on Running Hub. As always, in the cloud drive, I've shared the models, workflows, and nodes, along with the images I used for testing. Those with high VRAM can try deploying it locally. Just follow the environment requirements from the node's address to install step by step. Once you have your model, you can send it directly to an online 3D printing service to have it printed as a small figurine. If you're using it as a game asset, this workflow will save you a lot of early modeling work and improve your efficiency. That is it for this video. If you found this content helpful, please like and subscribe. It means a lot to me. Feel free to leave questions in the comments. If there are updates to better open source 3D projects in the future, I'll continue to follow and cover them.